Okay, so today we're going to look at a section on 7.4. It's the properties of logarithms. Okay. We're going to look at the product property. We're going to look also at the quotient property. And then we're going to look at the power property. So I want you to take your time as you go through here. This is the one time that you can tell Ms. Rivera to be quiet and slow down and take your time. So stop these, go back through, look at what's happening as we expand these and we simplify them and we condense them. Look at what's happening, because if you can master the 3 rules, then you're pretty good. Actually, you're not pretty good, you're very good. You know, these little rules, just these basic rules, are all you really need to know. We're going to do this one, and then we're going to do the change of base. And that's all you need to know to really solve any log equation. So I want you to just take your time on this section. Don't feel like you have to rush through it. So the first thing that we're going to do is we're going to look at the multiplication property and the quotient property. And what you're going to notice here are some similarities between the exponent rules that we used and the log rules. Think back, when we used to multiply exponents with the same base, we added those exponents. When you divided exponents with the same base, then we subtracted the exponents. Notice that as we expand these 2 examples, it's exactly the same thing. When we multiply, we add. When we're dividing, we subtract. Okay? So 3 to the 6 times 3 to the 4 is 3 to the 6 plus 4. And 3 to the 6 divided by 3 to the 4 is 3 to the 6 minus 4. Remember those exponent rules are going to come into play. Because remember, a logarithm is another word for exponent. Okay, so we're going to take the log base 4 of 64 minus the log base 4 of 16, and we want to write it as a single log. So since we are subtracting, we know that we're creating the single log of log base 4 of 64 over 16. Single log means that you write that word log one time. And log base 4 of 4, what number do we raise 4 to get 4? 1. So the answer is simply 1. But notice how it took that string, we condensed it, and then we evaluated it. So let's look at the quotient property. The quotient rule says that this isn't the quotient rule, this is the power property. Okay, so this is the power rule. Notice that in the power rule, what happens is that your coefficient, your exponent becomes your coefficient. Notice that the 6 log base 5 of x, that 6 becomes my exponent. Because I'm adding, I know that to rewrite as a single log, I have to just multiply. So take a minute and look at the model that you have, and then look at how it plays out using a combination of the power property and the product rule. Some more examples for you. So here you have the 3 log x minus the log of y plus 4 log z. Notice how the 3 becomes the exponent only for the x. The z has the exponent of the 4, and the y is division because we're subtracting. So your final answer is the log of x to the 3rd, z to the 4th over y. So we have log base 2 of 50 plus the log base 2 of 10 minus 3 log 2 of 5. look how this simplifies. Notice that my 3 for my coefficient became my exponent. The log base 2 of 4 is the number that you would raise 2 to get 4. So it's 2. Four times the log base 7 of x minus the log base 7 of y. That's going to be division. Because the 4 is outside the parentheses, this time it does affect the entire expression. So it's x over y to the 4th. Here we have 1/2 log x plus log y minus 5 log z. The 1/2 goes with the x and y. The 5 goes with the z in the denominator. So here we've used the product rule, we've used the quotient rule, and we've used the power rule. So we've used all three things to condense this, again, into one single logarithm. So now we're going to start with the single one, the single log, and we're going to just expand it. So here you have the log base 7 of t divided by u, which becomes the log base 7 of t minus the log base 7 of u. We have the log of 4p cubed, which is going to be the log of 4 plus 3 times the log of p. Your exponent comes down, lands on the ground, and becomes your coefficient. The log base 4 of 4x cubed square root x is going to be the sum of 3 different logs. Notice that the 3 comes down only for the x. Remember that the square root is the same as the 1/2 power. And so we break it down into 3 parts. Here we have the log base 3 of xy over z to the 4th. So, very simple again. Once you understand the rules, the 2 on the top are products, so we're going to break them apart and add those logs. The 1 on the bottom is division, so we're going to subtract it, and then that coefficient comes down in front of the log of z. This one's going to simplify to the log of 10 plus the log of 4 minus the log of x, and this 1/2 of that. Ta-da. Here we have the log of a to the negative 1, b over c to the negative 2. When we start to break this out, the first time we do it, we're going to keep the negative exponents. Becomes the negative log a plus log b plus 2 log c. Notice that the negative 2 for the exponent for c came down. Now, what if I rewrote this with just the positive exponents? What if you did that first? Like, I like to be positive, so we're going to write this with positive exponents. Okay? We have log of bc squared over a. Becomes the same thing. Becomes exactly the same thing. It would be the log of b plus 2 times the log of c minus the log of a. So if you don't like negative exponents, don't use them. You can't just throw them away, but you can rewrite the expression where you're more comfortable with it. So your calculator will only do, or your calculator only does common logs, which are base 10. So what if you have something that you want to do on your calculator, but you can't because it's in different bases? Well, we have a rule for that. And it's simply the log of base m is equal to the log of some common base, m, divided by the log of some common base, b. Notice that the m is on the top and the b is on the bottom. This makes it much easier for you to utilize the power of your calculator. If I have the log base 6 of 12, I want to rewrite it as a common log. It's simply the log of 12 divided by the log of 6. Must be careful with your parentheses on your calculator at this point, or you'll get some weird answer, okay? Notice that I would have parentheses. I'd close the parentheses at the 12. I would do the division and open it and then close that. Notice also that I got a constant, 1.3869. The constant is the result of the division. Remember that the log of 12 is a number. Represents the exponent that you would raise 10 to get 12. The log of 6 is a number. It's the number that you would raise 10 to get 6. So since they're both constants, they divide out and I get a constant. Let's do another one. The log base 3 of 11 is simply the log of 11 over the log of 3. Right now my common base is 10. So I'm doing a common log. I don't have to worry about writing anything else. There's an assignment on Math Excel, and then there is a daily check, which your substitute will have the password for the daily check. So let's go ahead and get the homework done. Let's get the assignment done, and then you can come back and do another video tomorrow.